So, hi everybody, and welcome to this small lecture on Consulate temperatures, and especially we'll be discussing about three binary systems. One is your phenol water, then trimethylamine water, and your nicotine water system. So, let us jump into that. So, firstly, when you discuss about binary solutions, binary liquid solutions, you have three types. One is your completely miscible. So an excellent example is your water ethanol system, where water and ethanol are soluble at all proportions at all temperatures. Second is your completely immiscible. An everyday example is your oil and water. So oil and water do not are not soluble into each other at any temperature or composition. The third one and the most interesting is your partially miscible. So, for example, if you take one butanol in water, okay, butanol water system. One butanol water system. Now, this represents a partially miscible system, where if equal quantities of one butanol and water are shaken together, now the mixture slowly separates into two layers. The bottom layer is saturated solution of one butanol in water, and it contains about 8% of butanol by weight, while the top layer is not pure 1-butanol but a saturated solution of water in butanol, and it contains about 32% of water by weight. Now, a pair of liquids like 1-butanol and water, which separates into two layers but still partially mix, is said to be partially miscible system. So, now if a graph of composition of the solutions and the corresponding temperature is plotted, usually here we are plotting temperature and composition. I will come to this, how this is derived. Okay. So composition. So I want to take this as pure A and pure B. So you get a curve which is known as solubility curve, and something like this. Let me. Okay. You get a curve like this. So let's explain this curve first. Now what happens is here at suppose I want to take this temperature. Okay. Now if at in this composition range where pure B is way more greater than A, so the at this point, okay, the mole fraction of A in this phase is going to be different. I want to call it as XA in beta phase. Now here, where pure A is way more greater than pure B, now the composition here I want to represent it as mole fraction of A, but in alpha phase. Note that alpha XA alpha and XA beta, although represent the composition of the same A, but in different phases, are not equal. They vary depending upon which side the composition is greater. Now, the composition of the two solutions, Okay, now along this curve, now when the temperature is raised, you see when the temperature is raised, what happens is the composition of the two solutions become closer to each other. Okay, and this is because there is an increase in mutual solubilities of two components as temperatures rise. So this happens in most of the cases. Okay, so as the temperature is raised, the compositions of two solutions, they become closer to each other. At a certain temperature, the composition becomes identical. Okay, and both the solutions merge into each other, thereby forming a single solution. Now this temperature is called as Consulate temperature, or CST, critical solution temperature. So here what happens is, inside this curve there are two conjugate solutions. Okay, and above this curve there is only one solution. Anywhere above this curve there is only one solution. So which means when a temperature greater than CST, or this Consulate temperature, the two liquids are miscible in all proportions and thus form a single solution. Okay, now few things to discuss here. Now what will be the freedom of degrees here? F, you know, is F is equal to C minus P plus 2. Here components are 2 but phase is 1 plus 1, so it is 3. So outside the curve, now if you keep pressure constant, so pressure has been kept constant for this. Okay, you have to tell both the temperature and compositions to completely specify a position. Here what happens is F is equal to C minus P plus 2, two components, two phases plus 2, so which is 2, and again here pressure is kept constant. So other than pressure you need to specify only one, that is either temperature or composition, to completely specify the point. Okay. An example that shows phase diagram something very similar like this is your water phenol system. So you have temperature, you have composition, and since this is higher, it's called upper Consulate temperature. It's so above that temperature, the solutions are, the two liquids are miscible in all proportions. So for water phenol system, the upper Consulate temperature happens to be 65.9 degree Celsius. Okay, so here two liquids will be present under the curve while only one liquid will be present. So which means it is completely miscible at all proportions above this Consulate temperature. Now this is not always the case. Sometimes what happens, if you take the case of triethylamine and water. So essentially here what is happening is, as the temperature is increasing, the mutual solubilities increase. Okay, as temperature increases, mutual solubilities increase. But that may not be the case always, where as the temperature is increased, the solubilities may decrease. Okay, so in that case you get a curve something like this, and analogous to an upper consulate temperature, you also have a lower consulate temperature. An example showing a curve like this is your triethylamine water system, okay, whose lower consulate temperature is I think 18 degrees. How much is it? 18.5 degrees. Okay, this is your lower. So reason why does this happen? Why does this happen? So let us discuss on these lines. So systems showing lower consolate temperatures almost invariably consist of either a hydroxy compound and an amine, or a hydroxy compound and a keto group, or even a ether group would do. Now what happens is, these compounds, the two components are partially associated through hydrogen bonding. Now if you take your hydroxy compound and your amine, right? So there is a hydrogen bonding that is present. Or if you take your hydroxy compound and your carbonyl group, your keto group, so there is a hydrogen bonding that is present. Now what happens is when the temperature is increased, now temperature increase means you are providing thermal energy. Thermal energy means what? The weaker bonds will break. So which is a weaker bond here? Is it the covalent bond that is there here, or the hydrogen bond? Of course the hydrogen bond is a weaker bond, so hydrogen bonds will break. Now as hydrogen bonds break, their mutual association decreases and therefore their solubility also decreases. So the extent of such association depends on the temperature of the system, and it increases with increase, and it increases and it decreases with increase in temperature. So that's the reason why mutual solubilities decreases as temperature increases. So this was your example for lower consolate temperature. Now there are also examples where let me take a new page, where you might have a lower consolate and upper consolate in this fashion. You have temperature, you have composition. So you might have a upper consolate temperature and a lower consolate temperature in this fashion. Okay. Now this might also be modified to something similar like this. You have temperature, you have composition, and you have a okay. So you have a lower consolate temperature here, and you have an upper consolate temperature. An example of this system is your nicotine-water system, where inside this circle you have two liquids, and outside is your only one solution, which means here it is soluble in all proportions. So for nicotine, it is the lower consolate temperature is around 60.8 degrees Celsius, and upper consolate temperature is 108 degrees. So in fact, at 1 atmospheric pressure, the water starts boiling at 100 degrees Celsius, right? So if it is 208 degrees Celsius and if it is still a liquid, which means you are dealing with higher pressure. That is important. Okay, and higher pressures of about I think 20 bar, 20 atmospheric pressure is employed here. So that was about your nicotine water system. Yeah, thank you so much. So this is very, very important. Please go through this.